Hi, my name is Brian. Welcome to another video on derivatives. In this video, we are going to find dy dx on this using implicit differentiation. Now, in order to find dy dx, we are going to have to differentiate both sides. So let me set that up right now. So we have d dx of 1 over x plus 1 over y. On the right-hand side, d dx of x over 2y. So let's take a moment just to figure out what it is we have to do. Now, anytime we differentiate a function like this, I do want to write it as x to a power. So this I'm going to rewrite as x to the negative 1. The same thing is going to happen here, where I'm going to write that as y to the negative 1. And over here, I am going to have to do the quotient rule. Okay, so now that I have an idea of what I'm doing, let's start this problem. All right, I'm going to differentiate x to the negative 1 with respect to x. So this negative 1 will come down, become x to the negative 2, and that's it. Now here, I'm differentiating y with respect to x. So that's going to be the extended power rule I have up there. We're going to bring the exponent down. We're going to leave y alone, and then subtract 1 off the exponent. But as the extended power rule shows, you're then going to have to multiply by the derivative of y, which is dy dx. Now on to the right-hand side, the quotient rule, which I'll put up there, you're going to have f prime g minus fg prime over g squared, which you can also use the low d high minus high d low over low squared to remember the quotient rule. So I'm going to start off with the x prime. So I'm not actually going to differentiate the pieces yet. I'm going to leave the g alone. So there's your low d high minus high d low all over low squared. Okay, so this side was still done, and so I'm just going to rewrite it. So y to the negative 2 dy dx. Okay. Differentiate x, you get 1, so it'll be 1, 2y. Over here, you'll have the x. Differentiate 2y, well, it's just going to be 2, and then the derivative of y is dy dx. So all going to be over 4y squared. At this point, I want to be able to solve for dy dx. Now, I have this 4y squared down here, which would be a little easier if I can just multiply the 4y squared over to these two terms. So I'll have negative x to the negative 2 times 4y squared minus y to the negative 2 dy dx times 4y squared. That is going to equal the numerator, which I have as 2y minus 2x dy dx. All right, I have my dy dx here and here, so I want to bring those to the same side. You can actually see this simplifies a little bit. You have y to the negative 2 and y squared, so these actually cancel. Otherwise, let's move things around. So I'm going to take this piece, bring it over here, and then this 2y, I'll bring, actually the 2y stays. That goes, oh, this 2x dy dx, that's going to move over here. Okay, so we'll get negative dy dx. Now there's this times 4 here, which I can put out front. And then I'm going to add this piece over to the left, so that's going to be 2x dy dx. All right, this came over to the other side, so that's negative x to negative 2. I'm going to put that 4 out front. Y squared, and then plus 2y. Next thing is I'm going to factor out that dy dx, and that's going to leave the negative 4 plus 2x inside, and then that's going to equal negative 4x to the negative 2, y squared, plus 2y. And the last step is to divide this over to the right-hand side. So that's going to be dy dx. All right, we have our numerator. And then we'll divide by the negative 4 plus 2x. All right, we've completed the problem. We found our dy dx. I hope this helps. Good luck.